So welcome. Remember last time we talked about the Yahtzee game, we talked about separating the user interface from the game logic. What we want to do is build a solid brick wall between the two. We don't want to mix up the rules for playing Yahtzee with trying to get the UI to represent the game so the user can interact with it. It's always a good idea because a lot of times you want to switch out the UI, say, from a command line UI to a graphical one like we're doing right now. You want to make it very easy to switch out the UI and not affect the code that you wrote for the game. So what I've created here is called a finite state machine, or more academically you might call it a finite state automata. And what this represents is all the states that the Yahtzee game can be in, and we need to be able to handle those states and set the UI accordingly. To understand a finite state machine diagram is things inside the circle are called the state, and the arrows are called state transitions. Now when we start the game, it's immediately going to go to the reset game state. There's lots of ways to get to the reset game state. You can see all these arrows coming in. The first time you play, it'll reset the game, plus if you cancel out of a game and want to go back and restart, you see a lot of arrows coming in. There's only one way out of this state, and that's the user doesn't have to do anything to transition from this state to this state, which is before the first roll. It just does that automatically. But once you get to before the first roll, you have two exit points you're possible to do. The user can hit the roll button, or they can decide they want to start the game over again. So they can do that. And then it goes back to reset game, which as soon as it gets that, it sends it back to before first roll. Reset game will clear all the buttons and clear all the scores and just get the game ready to be played again. But say they do hit the roll button, so there's a transition from before the first roll to before the second roll. Before the first roll, you don't want to give them the ability to be able to choose one of the dice to hold because they haven't rolled yet. So you would disable the hold buttons, whereas if you're before the second roll, you want to allow them the ability to hold certain dice in their dice set for the second roll. So they press it again, and now they go to before the third roll is the state. They press the roll button one more time, and now they're after the third roll. There's only one way out, and that's to score. So if they choose a score category, right now we just have a score button, but say they choose a category, you go into the scoring state. If it's the last turn in the game, they don't have any more slots open on their scorecard, then the game's over. Otherwise, if there are still turns to take, you still have some empty categories on your form, then you go from the scoring state back up to before the first roll again. If you do finish up, then you get to the game over state, and you can either just quit the program or go back to new game, which will take back to the top and reset the game. I find these diagrams are really helpful because you can imagine you have a little player piece like a pawn from a chess game, and you can move that pawn dependent upon where you are in the game. And we're going to try to use these states to control how our user interface is going to look. So let's try to do that in code. Now, I've kind of pre-filled some of this in, so I'm going to show it on the screen, but you can pause the recording if I'm going too fast, and you can just copy in what I'm typing. The first thing we need when we're going to create these states is we need a set of constants that will represent each of these states. Each constant needs to be unique. And so what I've done is I've gone up here right after we're in the dice frame class. We want to create a set of constants that have a unique value. So I've typed those in beforehand, but the syntax for creating constants is you have the public keyword. Final means constant. Static means you can use the constant value without having to create an object of type dice frame. It's complicated. The data type, we're using an integer here, and then since it's a constant, we use all capital letters plus an underscore in between words. And we're going to just start numbering at 0. The next state will be before the first roll, just like on our diagram. Before the second roll, before the third roll, after the third roll. There's a scoring state and then a game over state. So overall, our game's user interface is going to be in one of these 7 states. Notice there's 7 because we start counting at 0. Now at the bottom, we need to add an instance variable that will tell us what the current UI state is. So I've already typed that in, but you need to add this right here. And again, it's just an integer, and it will tell, anywhere in your program you could ask, okay, what's the current UI state? And it will tell you, oh, you're scoring right now. And then you can take action based on that. So add that instance variable to the bottom of the class. Now remember, typically when you add an instance variable, you add a get and set function. I'm not sure if we need that, so I'm going to wait until I find a need for it. But we do have to initialize it. And we're going to initialize that somewhere in the constructor, but we're not quite ready for that yet. So going back up to the top of the source file, we've got our states. And now we want to create a method called manage UI state. And this is going to be the one that will allow us to set the user interface based on where they are in the game. So I've typed this in ahead of time, but I'm going to uncomment it right now, and then we're going to walk through each stage here as we add stuff to it. So imagine, I think where we left off was, well, we started from the beginning here. So I'm just going to comment them out until we get a chance to talk about them. Okay, break. I'll talk about that one too. So here's a method that takes as a parameter what the next UI state would be. Now the first one we're going to start with is before the first roll, at least for now. And so we use something called a switch statement. Now a switch statement allows you to branch not just in 2 directions like an if statement, but into multiple directions. So I call this multi-way branching. You can imagine you're at a switch yard on the railroad, and you've got to send the cars down one of more than 2 tracks. Maybe there's 7, maybe there's 8. A switch statement allows you to switch between tracks and look at it that way. So what we're switching on is what the next state is going to be. And the calling program will send in what the next state is, and then we'll switch based on that and choose the right one. Now you notice for every state we have a case. We say case, a space, and then the state that matches up. So we use the constants we just created. Some of these I haven't filled in yet. That's fine. Here's all the states. Now in the case that this manage UI state gets a number it doesn't know, we need to tell the user that there's a problem, because no point in the game should code in the game be sending an invalid constant, invalid number into the switch statement. So what we want to do is tell the player, but also tell the programmer that something bad happened. Now this is a really bad message. It would be better to say, perhaps you say invalid UI state detected. Maybe you would type that. Now we add the J option pane. Doesn't know what that is because we haven't imported it yet. So we're going to go back up to the top, and I'm just going to make sure that we import it, and that's right there. As soon as I import it, then it knows what it is, and it'll go. Invalid UI state detected. That'll tell the user, or hopefully the programmer, that hey, something's wrong here because we got a value we didn't expect. A lot of novice programmers wouldn't put the default state in there, but then you have this bogus value and you have no idea what the programmer will do if it gets something it doesn't know what to do with. You never want to hide your errors. You always want to make them really visible so that you can fix them. If they're invisible, then you can't fix it. We've created a case for each one of the states that we have on our diagram. Plus we've added this default case. Now at the bottom we want to set the current UI state to the next state, and that's the one that was passed in. So let's look more carefully at before the first roll. These are the things that we need to do in before the first roll. We have to disable the hold button so they can't click on them. We need to enable the roll button so that they can roll, because you're before the first roll. We need, if they're coming back to it, we need to clear the hold array, and that's the array that holds the true or false whether they are holding it or not. It's more of a game thing, not a UI thing. Those are the three things we need to do. So I've kind of typed this in earlier, but we have 3 new functions or methods that we want to add. First one of these is clear and disable hold buttons. It's going to do exactly what it says. It's going to clear all the hold buttons so that they don't have any numbers on them. It's also going to disable them so the user can't click on them. So that's the idea there. We haven't created these yet. We want to enable the roll button. We don't need a special method for that. We can just tell the roll button to enable itself. So mine's called JButtonRoll. I say .set enabled, and I set it to true because I want the user to be able to roll. Then what I'll do is, what we want it to do is clear the hold array, and this is where we clear all the trues out of the hold array and make sure that it's all set to false. Now I kind of misnamed the hold buttons here at the bottom, so let's go to the bottom here. I actually changed this. This used to be called roll buttons. It was kind of a bad choice. It'd be better to call them hold buttons instead of roll buttons, because we have a roll button already. I guess that's here, JButtonRoll. I've changed the name to hold buttons, and what you can do is you can just select it. This is already changed, but then you can say refactor, and then rename, and it will rename that item throughout the whole project. You don't have to find all the spots and rename it. You can do it that way. So that's how I did it earlier. So it's already been renamed to hold button. Hold buttons is plural. Usually with an array, I always make it plural, so it sounds like a bunch of them. That always helps kind of clear things up. Okay, so back up to our finite state machine. We're going to need then 2 methods. Clear and disable the hold buttons, and clear the hold array. And so I've constructed those down here. Let me just uncomment it so that we can see them. So here's the first one. Clear and disable the hold buttons. Since we know how many buttons there are, when you have a loop where you know how many times you need to go around, it's best to use a for loop. Usually in for loops you use the variable name I. It's just a counter, but that's kind of like, in most languages, that's the letter they use, I for index, I guess. There's an old language called Fortran that everything after the letter I, including I, was an integer. The programmers just kind of got used to using I as a index in an array loop. So we initialize I to 0. That happens only once at the top, or before you go in the loop. This happens at the top of the loop. It checks to see if I is less than or equal to the number of hold buttons you have. And then at the bottom of the loop, it's going to add 1 to I each time. So what things do we need to do to the hold buttons to get them ready, or to clear them and disable them? Well, first we want to clear the text off of the hold button. So here's our array, hold buttons, and then we index into the array. So the first time through is going to be 0. So for the first hold button, we want to set the text to the empty string, which means we want to clear the text. We don't want it to say anything, because right now it has a number on it maybe. Then we want to take that hold button, we want to disable it. So we say set enabled equals false. Finally, we want to make sure that it's not depressed. These are toggle buttons. In order to make them look like they're not already pressed, we say set selected, but we say false. Now earlier we had talked about using do click to uncheck it, but after some more research, this is not as kludgy as that. Kludge means it's not the best way to do the code. This is a better way, so we'll do it that way. And we'll do this loop 5 times, 1 for each button, and we'll clear the text, it will disable them, and it'll also unclick them if they're clicked and pressed down. So we've got that one figured out. But the other one we need to do is here, clear the hold array. This is the internal hold array. It has really nothing to do with the UI. It just tells the game that, hey, they're holding this dice, or they're not holding this die in the dice set. So again, we just have a really quick loop that we just loop through all the slots in the hold array. Same kind of setup. I would just copy what you have here, move it down here. But a couple of things that are different. First of all, what you test against is not the num dice, or it's not the hold buttons. This is basically the hold array. It's better if you're using the hold array inside the loop. It's better to use the same array to set the limit, how far to go. So I changed that to hold array.length. And then as I go through the loop, I'm just going to take everything in the hold array from 0 to 4. I'm going to set that to false, indicating that we don't want to hold it. All right, so we have those first two done. Now if we continue on down, there's a time when we want to enable the hold buttons. And that's when they're right before the second roll. They've done the first roll, and now you want to give them an opportunity to hold some of the dice before their second roll. So we need a method called enabled hold buttons. That's my name for it, I guess. And we want to enable those when we're in the before second roll state. I'm calling it enable hold button. Okay, so let's look down below. And again, I've kind of coded this ahead of time. And here, again, we just do the tight loop. And we say hold buttons on length. That's all the same as this one here. Inside disable. So that's the disable hold buttons. Enable hold buttons. So we just go through the hold buttons and we set enable to true. Okay, so back up to our finite state machine. We see we're really not doing anything special before the third roll, at least not yet. It still should allow them to hit the hold keys. So there's nothing different right now between those two. But after the third roll, we want to disable the roll button. So we're disabling it right here. So again, it's J button roll. That's the name of our roll button. And this time, instead of setting it to true like we did up here, we're going to set it to false because they've already rolled 3 times, so you don't want to let them roll a third time. Okay, so now we want to go down to the roll button itself, the event handler for the roll button. And what we had before was something like this. For each die in the dice, we check our hold array first, and if it's not being held, then we roll it, and we set the value on the button so that we can see it. We're keeping track of the number of rolls. And then if the number of rolls is greater than 3, then we disable the button. So we don't need this anymore because we're going to be controlling whether the button is enabled or disabled in our manage UI state method. So what we can do is we can just delete all of this. And instead, we're going to add this code here. Now, this is another way to do multi-way branching. These are called chained else ifs. But basically you're saying, if the current state is before the first roll and now they've rolled, we need to move the little pawn on our diagram to the next state. So we say manage UI state, and we're moving it to before the second. The num rolls is gone. If you go down to the bottom, then we're just going to get rid of it. Okay. Yeah, all of that is gone. Not the whole thing, just the num rolls. There was a section here that this all stays the same, but there was some stuff after it that we got rid of. Now you may not need to say if here. In fact, you could leave all of that out, but I'm just not sure yet. So we'll take another look at it. Usually when you do chains else ifs, the last one just says else, but I have to look at the machine a little bit more to understand that. So I'm going to wait. You can get to, if you look on the diagram, if you're before the first roll and they hit the roll button, you want to go to this before the second roll. And you can actually see it here and also look at your diagram, and it should make a lot of sense. Now we got rid of num rolls. Notice here that this has an error. It since we got rid of it, we also have to delete it in the constructor. This is the constructor for the dice frame. So again, we don't need it anymore, so we can delete it. But we do need to add something to the constructor. And once we're all done, we're going to set the UI state to reset game. But right now, we don't have anything going on in reset game yet. Just for the time being, I'm going to just say temp should be reset game. So I'm just writing a little note to myself to remember that I need to change that to reset game and not before the first roll. But for today's discussion, this is kind of how we have to do it. We kind of prime the pump that way. If there's anything else we need to do, I think that's everything. So let's give this a try and see if our UI works the way we think it should. Okay, so here's some of the new behavior. Note that, right from the start, I can't click on these buttons because they're disabled. Okay? If I say roll, that moves me before the second roll. 2, 3, 4, 5. Or I got 2 3s and 2 4s. I'm going to go with the 4s, let's say. Now this is my second roll. So now I'm before the third roll, or after my second roll. I didn't get any help. So I'll roll one more time, and still no help. But notice my roll button disabled. Okay, so I'm going to have to use this on my 4s maybe, on my score sheet. So then I click score. And notice how the buttons didn't get cleared, and there's still numbers on the buttons. Okay? So we have to take care of that problem. Let's go back into our program then, and we want to go to the event handler for the score button. That's roll. Here's score. We used to have a lot of junk in here. What I did is I replaced it with one simple thing. We were trying to manage the UI state when they hit score, and it got really kind of messy. And so I deleted all of that code and replaced it with this. Now eventually you'll have to check to see if this is the last turn in the game before you go to before the first roll, but for now we're just going to say if they hit the score button, we're just going to set the UI state back to before the first roll again. So go into the event handler for your score button and change that to manage UI state before the first roll. Yeah, the whole thing, and just replace it with that. And that's what's neat about it, is you can now take all this UI state management and move it out of the game logic and put it in the UI logic instead. You want to say manage UI state, and now we're going back to before the first roll. If you look at your diagram, we're scoring, and we have a choice to make. If it's the last category, we go there, but we're not coding that yet. So we're just forcing it to go back up here to before the first roll. So that's how our code matches up with our diagram. So here we still have more to do. Need to test for last turn. We'll call each set of 3 rolls a turn. That's what I usually call them. So it's still some work to do there, but now it's a lot more straightforward. Okay, so now let's try it and see if it behaves the way we want. So we're going to roll our dice. We've got 3 6s right off the start. That looks good. So here's my second roll. We've got another 6 going for Yahtzee. Roll again. Ah, darn. So now I score. Now the hope is when we hit score, it's going to clear all the buttons, unclick them, and disable them, because we'll be back to before the first roll. That's what it did. I can't click on them. I say roll. Oh, okay, cool. Got 2 1s. Let's see if this stays working. Well, I got 3 5s. So that's a full house. I'm going to score right there. I know I'm before my third roll, but you can score at any time after the first roll. Yeah, now if I go again. So now you can take this dice roller, and what I would recommend is grabbing an empty score sheet and play Yahtzee. You don't need any dice now because you have dice that do that, and it keeps you so you can't roll more than 3 times. And every time you write down a score on your score sheet, just hit the score button, and that will reset it for the next time you play Yahtzee. Eventually we'll have the whole user interface, but for now I think we have enough to actually play Yahtzee without dice, at least. We're relying on the random number generator inside of the Java language. Right, I think that's it.